All right, good morning, everyone. My name is Cole Harrison. I'm a data scientist at Credera. And before we get started in our conversation today about MLOps, a quick thank you to our title sponsors, Amazon, Capital One Cafe, Delphi Startups, and the Downtown Denver Startup. This session is part of the developer track sponsored by Quizlet, one of 8 programming tracks aimed at supporting the entire entrepreneurial team. By attending this session, you're agreeing to follow DSW's code of conduct as well as being photographed or recorded on video as part of this session. Be sure to share your experience of the session online at #DenStartupWeek. Now, as I said before, I'm Cole Harrison. I'm a senior data scientist at Credera. And Credera is a global boutique consulting firm. We serve clients all over the globe. And today we want to talk about how we're using MLOps to serve our clients to enable scalable machine learning solutions that drive enormous business impact. I'm joined today by Amanda Aschenbrenner, who's a senior architect in our data engineering capability, and Matt Patterman, an architect in our data science capability. Yeah, so it's a really, really exciting time to be in the field of AI and machine learning. Right now it's touching just about every single field, every single industry, and touches just about every single business. At Credera, we're doing some really interesting things in AI and ML. Our data teams are working on a variety of projects in different sectors and different industries, some of which are we're doing automated data extraction with document intelligence at a large logistics client. We're also building recommendation engines at a travel and hospitality company. That's kind of like our recommendation engines, what you see on like Netflix or Spotify. We're also developing approaches for anomaly detection at a large oil and gas client to facilitate preventative maintenance on big, heavy, expensive equipment. So that's just a couple of things we're doing in the ML space right now, but I want to talk a little more about broadly what's happening in the field of AI as a whole. So let's talk about AI. And before I get kind of deeper into it, the team will be using the terms AI, machine learning, and data science somewhat interchangeably today, so you just kind of lump those terms together in your head for the rest of the presentation. So what exactly is AI? AI is the simulation of human intelligence processes by machines. And that probably doesn't mean that much to you, like a little Merriam-Webster dictionary definition there. So what exactly can it do? Well, the limits of AI are kind of boundless right now. And you've probably already heard of some of the recent advances that AI has been making in the news. Some of the examples of that are here. So you can see AlphaFold, which is a model developed by DeepMind that's currently helping facilitate medical research at rates that are unprecedented. You have SpaceX, and you all know about SpaceX and the rockets that are landing themselves. What to do, that's also AI. You can also see Netflix here is making $1 billion annually from personalized recommendations, which, if you think about that, that's pretty crazy, right? Like $1 billion every single year from an automated system with no human required, like bananas. And lastly, InRide is another example of how we're using AI and machine learning to impact the world. InRide specifically is a company that just got approval in the US to send out fleets of semi-trucks that are autonomous. And so you can see the scope of AI and the power of AI is pretty broad and pretty incredible. And as I just mentioned, InRide, we actually have a quick demonstration from them showing just how impressive these models are starting to become. So you can watch that real quick. Pretty wild, right? So what's the headline there? Well, AI allows you to automate processes that humans never before thought that would be able to be automated. just as another example of the power of AI, before the presentation today, I asked GPT-J, a large language model created by Eleuther.ai, to create my conference talk for me. And you can see that the output's pretty astounding, right? Some pretty eerily realistic outputs from relatively simple input. So you can see the human input here. Hi everyone, my name is Cole. I'm a data scientist at a global consulting company, and I'm going to talk today about the value of MLOps. And you can read a little bit into the output here, but the key things to take away are essentially that, one, it understands how to give a conference talk from that basic input. It knows that, hey, I'm going to need to continue talking in the style of the presentation. It also is able to understand that, hey, like language, it can essentially string words together and put somewhat coherent thoughts together, and it's going to continue to improve over time. And lastly, it understands MLOps, which is probably more than the average person at the end of the day. And you can see there, at the last sentence that's bolded, so you're trying to take the data and create models, you're trying to do that at scale, and then you want to put the model into production. So that's what MLOps is all about, which that's exactly what MLOps is all about. So pretty wild stuff. But I want to talk a little more now about what's the actual business value of AI and machine learning. Right now, the global AI market is worth $136 billion and is expected to generate $15.7 trillion by the end of 2030. And in the next 5 years in the US market alone, our market will be worth $407 billion. And like that doesn't necessarily mean that much to you, but to put that in perspective, that's larger than the GDP of Norway, the GDP of Finland, Israel, Hong Kong, and many, many, many other countries that you know of. So you also have to realize that that's all automated systems generating that value. So immense value there. And that makes sense, right? Because if I can automate entire business verticals that previously required entire teams to run, obviously you're going to unlock tremendous impact in cost savings, revenue potential, and peace of mind for your clients. So naturally, 87% of companies think that AI will bring them a competitive advantage. And 83% of companies have AI as a top strategic priority this year. Which makes sense, right? Why wouldn't you want a slice of that gigantic pie? However, even companies with really large data science teams often struggle to unlock the value that AI promises and that the hype kind of surrounding AI promises to deliver. So to talk a little more about that, I'm going to pass it over to Amanda to talk about some of the challenges in implementing scalable AI solutions.
Great, thank you, Cole. So amazing what we can do with machine learning and AI, but generating this value is proven to be really hard. And we've been working on a lot of it, so I can attest. But take it from other third parties. Google has termed machine learning as the high-interest credit card of technical debt. And why is that? 50% of data scientists' time is spent actually working on maintaining models and technical debt type work. And the other 50% is spent on innovating and building new, really complex models like some of the ones that Cole just demoed for us. But 90% of those, where you're spending that 50% of innovation time, never actually make it to production, because this is really tough. So what makes it tough? So if we look at the traditional machine learning lifecycle, our data scientist on the right here, spending time understanding our data, doing exploratory data analysis, collecting the right input data, cleaning that data and transforming it, selecting the right model for the business problem at hand, and then training that model and getting it to a place where we're confident enough to release this either to our customers as a recommendation engine or bake it into a data product like autonomous vehicles. So at that point, in the traditional ML lifecycle, data scientist, here's my model, it's awesome, great metrics. Here you go, data engineering team, over the data science boundary to another team. And as you can imagine, when you're passing off to a new team, not a lot of cross-functional work being done to date, there's a lot that can go wrong in that process and while the model is actually in production. So to summarize some of these pain points, and we did exhaustive research on this, so I will bring it up into some categories for you guys. 3 main categories here of pain points that can happen for organizations that adopt ML. Visibility. So now you have a product that we want to put in front of millions of customers. it's no longer just the data science team's business how that model is performing, and building trust and confirming and making sure that we have the right controls in place so that the model doesn't go rogue, because it can. It can make faulty predictions, it can adjust to, or lack of adjustment to new data, and can cause a lot of issues. So we need a robust monitoring system and alerting system that spans past data science to your data engineering team, your software engineering teams, your product manager, who now owns this data product. And they need to be aware and see constant visibility there. Long-term accuracy, so how do we know our model is still performing highly in 6 months, a year from now, right? Data science team and data engineering team has put it out there. How do we know it's still performing well? And an example I can give here is one that kind of makes data drift really apparent. So seasonality. So say I am an e-commerce shoe site, and I trained a model on data from May and June, got really good confidence that you love your boat shoes and your flip-flops and everything related to summer-related shoes, right? Next year, I'll have data on what you bought and what you're interested in for fall, but this year I don't. And so we need to do some manual input to start, but we need to train the model and make sure that it can automatically retrain on shifts in data that show you've come to our website, you've clicked around on some closed-toed shoe options. We start to immediately adjust and show you recommendations that are right for the season. And then lastly, slow deployment and development times. So this, importance in the timing rolls into that same example I just gave, right? We're buying shoes for October and November now. So we need to be showing you recommendations for those options early and predict that that's what you're going to buy and what you're going to be interested in. So it's very important to get the data quickly, adjust, retrain your model, and get a new model back out to customers. So how do we do that? What you guys are all here to talk about? Thank you for bearing with us for that first 10 minutes. To set the context, so machine learning operations. Machine learning operations is that set of practices that we put in place to ensure that you're preventing and combating issues with productionalized and maintaining models. Two things I want to touch on that go beyond our definition here. One, it's highly cross-functional, like I mentioned earlier, right? So we have an idea for recommendation engine from the get-go, and I'm actually working with Garrison on a project like this now. We need product, software engineering, and data, which is our new team that we're bringing into the room, to solution and work together on this. And the other piece that I want to touch on is that machine learning ops steals in a smart way, a lot from DevOps, which proved versioning, automation, and a continuous integration and deployment process 15 years ago when they implemented this for software engineering. So we're borrowing a lot of that. Obviously, there's additional complexity now that we have machine learning in place. So to kind of visualize for you guys, what does MLOps encompass? What we're looking at, what we talked earlier, the data scientist's role of collecting, cleaning, training, selecting a model, that's all fitting as one small piece in this top light blue box, MLOps sandbox. This is where we experiment. It's where we figure out what are we going to do, what do we want to do, and all the rest, like the majority of the work to get this thing to production, is not traditional ML lifecycle. So this is a referential architecture that we've built to help people figure out, what else is included in MLOps and what else do I need to build. So we have the deployment process that I talked about for CI/CD. We have the monitoring or robust monitoring that I talked about earlier. Specific factory triggers. So, for example, in the e-commerce shoe example, we have new data for fall, automatically triggering a retrain into what we've termed a model factory, but essentially infrastructure as code that retrains with the new data set, produces a new trained candidate model that's being stored in our model registry to be used. And then how do we get it to the e-commerce website and in front of all of us? We have a consuming application. In that example, it is our shoe website that is asking via API for the recommendations for Amanda, or the recommendations for Bobby in the room, and displaying it to that end consumer. So that is everything that's encompassed in an MLOps system. And now to bring it to life, I'm going to pass it off to my colleague Matt, and he's going to take you through tooling and different tools you can use for all these components, and then a demo of one of our accelerators in the Azure stack.
Thanks, Amanda. So now that we have a good conceptual understanding of MLOps, let's take a look at some real hard steps that Credera has made to position itself within this space. So the first thing that we want to call out is that businesses will vary their needs and priorities drastically based on their size and experience in this field. Whether you're an up-and-coming startup that's looking to get your first model out the door, or you're an experienced player looking to further refine your pipeline, Credera has built a series of data and ML maturity models that allow us to come in and assess a client and really understand what is the core need that they have and how can we best deliver value on top of that. And in addition to that, we're not just peddling shovelware either. We have conducted countless interviews with a whole bunch of MLOps players to kind of understand where they all play in the space and how they can work together. In light of us being at Denver Startup Week, we thought we would call out specifically what are kind of the good players to work with if you're looking to kind of get something out of the door right away and you might not necessarily have that kind of super experienced, robust DevOps system. So we would say largely focus on those large players and specialized players. They offer kind of concrete solutions that are easy to kind of one-off or integrate with a junior system. The one downsides are that they generally come at a higher cost, and integrations might be a little more difficult if you already have built up a system. That might be when you move to something like the Cloud Suite and start leveraging a series of AWS services. And lastly, I just want to emphasize that cost again. There's a lot of understanding about what is the cost of a single machine learning inference in a pipeline like this. And honestly, custom solutions offer tens of thousands, if not hundreds of thousands of inferences for a couple pennies or $1. But a lot of these APIs are offering their single inference for 50 cents or $1 or more. So unless you're really generating a lot of value off of the inferences that you're making, it may be best to assess some type of custom solution. On to the next one. So now let's take a look at a demo that we put together demonstrating our kind of reference architecture over an Azure ML Studio and Azure DevOps scenario.
Let's take a look at how we practice MLOps in Azure. Today, we're simulating a scenario in which for business owners seeking to report the amount of foot traffic we're generating on a daily basis to customers to allow them to understand when we're busiest. This is a time series forecasting task, and the consuming application will be a website which displays our busy days to users. We have two services we're going to be using. Azure DevOps publishes and orchestrates our machine learning pipelines, while Azure ML Studio centralizes our machine learning operations and provides a nice UI to manage our data, model registry, and other MLOps components. Let's assume we have training data from May and June 2022, which we've already preloaded into our Azure environment here as a data set. Our first goal will be to use this data to train an initial model which will forecast foot traffic through the end of the summer. This is where our model factory comes into play. To train our model, we head over to Azure DevOps, click on our training pipeline, which is our model factory. It trains our model and then registers it in our model registry. And it's a 2-click process to get started. We hit run pipeline, we hit run. We're gonna let our pipeline execute and we'll be back when it's finished. We're back and it looks like our training pipeline finished. So we can actually drill down here and see that each of our individual steps executed successfully, which is great. And while our time series forecasting task doesn't require the use of inference, for other use cases, we have also set up batch and real-time inference pipelines in Azure DevOps to set up those components as needed in Azure ML Studio. So now if we go back over to ML Studio, we should see that our model artifact is registered in our registry and is now available for use to hit as an endpoint by our downstream website that will display our forecasting data to users. If we go over to our pipelines tab here, we can also see that our training pipeline is now set up in ML Studio and is available for reuse. And if we go to our job history, we can look at our output from our training run. And we don't have any outputs or logs or metrics for this particular run, but the important thing here is the plot. So we see that we have 2 months of training data, May and June, and we have 2 months of forecasting. So orange represents the output of our ARIMA model, basically trying to predict what will happen for the next 2 months. So we see a pretty consistent oscillation here representing peaks on the weekends and valleys for the weekdays. Essentially, this might be where customers are more able to come in on weekends because they're off work, something along those lines. And we see that our ARIMA model is able to effectively represent those peaks and valleys. We see that pretty well represented here. So let's make this a little more interesting and say that we begin a promotion at the beginning of July, which offers heavy discounts in store on Tuesdays. Let's also say that we've set up an automatic training job at the end of each week. So we waited a week into July and we have an additional week of training data. Let's say that we've added that off screen here to our existing data set. And let's also go ahead and manually kick out that pipeline instead of waiting a week. So we're gonna just go into ML Studio. We actually don't need to go back to DevOps for this. This is now set up in ML Studio. With the existing experiment, we have some configurable parameters here, but these are pretty simple. We're gonna kick this off and we'll come back when the retraining job is ready. We're back and our retraining job finished. So let's take a look at the job history and view the new forecast plot. So in addition to our 2 weeks of training data for May and June that we had in the initial run, we now have an additional week of training data corresponding to the start of the promotion in July. And so we see this additional spike, which corresponds to Tuesday, basically indicating that we had an influx of customers taking advantage of that new promotion. And so we see that our ARIMA model is still representing those peaks and valleys for weekends and weekdays respectively. And it's having some difficulty with the new spike. So we see some kind of spike on Tuesdays, but it's not quite at the magnitude that we expect from that additional week of training data. So what we're gonna do now is simulate adding in the rest of the weeks in July as training data. We're gonna retrain our model each time, simulating our automated training job at the end of each week, and we'll see how the data looks after we add each week. This is the plot for our first training run, and as you recall, we had our first 2 months of training data, and our ARIMA model did pretty well at picking up the peaks for weekends and the valleys for weekdays. When we added an additional week of training data corresponding to the start of the promotion period in July, we saw that our ARIMA model had some difficulty picking up on that additional spike for Tuesdays, but was still representing the peaks for the weekends and the valleys for the weekdays pretty well. After our second retraining run, we see that our model did much better at picking up the magnitude of spikes that we expected for Tuesday, and also continuing to represent those peaks for the weekends and the valleys for the weekdays. When we add a third week of training data for July, we see that our model is fitting even better. And when we add a fourth, our model is pretty representative of the month of July when that promotion started. Each new time our model is retrained, the endpoint will reference the latest model version, allowing any visualizations on a downstream website to automatically leverage the most accurate and up-to-date version of our model. As a result, our website would automatically adapt to the new foot traffic caused by the promotion, and customers would know that they can expect Tuesdays to be high volume days in our store by looking at the forecast on our website. So you can see how MLOps allows you to quickly and efficiently iterate on your models to adapt to changing dynamics of your business.
Okay, so what did we just see there? If you're inexperienced in something like DevOps, you may have just saw some guy hitting a bunch of random buttons and maybe some machine learning happened. If you're experienced in Azure DevOps, you may go, wow, those guys actually had a lot of machine learning running on there. But what we saw specifically was demonstrations of our model factory, our model registry, those optimized CI/CD deployments, all working together around the data scientists, so that data scientists can focus on the work that matters and not having to worry about all the data engineering that's commonly associated with these problems. Now, in addition to the reference architecture and what we've built on top of Azure, we've also built the equivalent for AWS and GCP, as well as made these components rather robust in the fact that they can be used and leveraged alongside third-party services that a client's already using. So what does these address? The so what, why does it matter to you, why should you use MLOps? Well, conveniently, all the problems that we highlighted with machine learning earlier in this presentation, they're right up here and they're all solved. Wow, that's crazy. So how do I know my model's still accurate in 6 months? We provide automatic retraining, data drift detection. How do I combat data drift in my models? That automatic data pipelines that ingest your data and seamlessly integrate with your data lakes. Slow deployment times, as you saw, our deployments take seconds, not days. All it is a single click of a button, and the model is automatically replaced in our endpoint. It still seamlessly integrates with your existing APIs. And then lastly, visibility. With MLOps, you have the ability to kind of know when your model's going wrong, when it's going rogue. You have access to all sorts of additional metrics of what were those accuracies, what was the time it took, what was the cloud cost of running that inference. So it really lets you kind of not only understand what was the model's reasoning, but what's the overall success and health of the solution that I've implemented. So now that you guys are all aware of the wonderful impact of MLOps and the value that it can drive, we thought we would call out some resources for you guys. So if you're interested in learning more, you can feel free to check out our Credera blogs that kind of detail MLOps and our reference architectures. And then lastly, if you're a little bit ambitious and want to learn some of this by yourself, we've outlined some certifications that a few of us have gotten that kind of really helped facilitate our better understanding in the MLOps space. With that, we've been Credera. Hope you guys like MLOps. And we'll take any questions.
Sorry, can you just go back a slide really quick? Thank you.
Which question?
Yeah, so let's say a startup has some type of value prop, and they want to go through some sort of like POC pipeline, kind of like the demo was. What was the cost, or like what's a ballpark for, let's say, a month of proving that out?
In cloud costs, you can actually get it down pretty low. So like if you're running a whole bunch of interoperable parts on like a Kubernetes cluster, I think that's a couple bucks a day. So maybe in the hundreds of dollars, definitely not in the thousands of dollars. But even then, if you wanted to scale up and run inference, like we said, there's really cheap cost solutions for that. So I would say in general, be prepared to spend a couple $100, but cost mitigation can really keep it on the lower end.
It also depends what kind of model you're running, right? Like, for example, Matt's working on a client right now where they're using TensorFlow models that they can convert to TF Lite, where now they can run their entire inference on a Raspberry Pi if they want to. Yeah, so it really depends on what you're running and what the requirements are for inference at the end of the day.
Any other questions? Yeah.
What was the name of that predictive speech writing?
Yeah.
Oh, yeah.
That was called GPTJ, and it's built by a company called Eleuther.ai, based on OpenAI's GPT-3.
Okay.
But recently, there's a lot of different large language models that have been made publicly available. So if you want to look into that more, Hugging Face is a resource where you can go look at publicly available weights for Bloom and for the OP models, which is for Big Science and Meta, respectively. And there's a bunch of other large language models that are they're made basically every other day, and they're coming up with another one. So.
Yeah, and the real fun thing is that these used to be, they're 100 billion parameter models. There's more parameters in them than neurons in the brain. They used to be locked down and cost a lot to kind of run these inferences, but there's been a lot of recent developments that have offered open source alternatives. So GPTJ is free to use. You can download the weights online. Same with something like Bloom, which is now kind of the gold standard when it comes to language models. So.
They're a little scary because this is the start of the AI revolution. I feel like.
Yeah.
But there's a whole lot of possibilities from this. Natural language generation as a field is still pretty new, and people are still trying to figure out how do you get reliable outputs from these models. But it's a really, really fascinating area.
If you're interested in working more with them, there's a kind of field developing called prompt engineering, which is all about how do you talk to these large language models and get them to do what you want.
On your last slide, you had the three big platforms, the Azure, AWS, and the Google Cloud, and you said you built these pipelines on all platforms.
Yep.
So do you have any recommendations in terms of pipelining, in terms of machine learning, and in terms of certifications, and what direction you think that's a
Yeah. So a bit of background, I'm a very much like do-it-yourself kind of programmer. It drives me nuts when someone's trying to charge me $1 gajillion for an OCR technology when there's a free one from 20 years ago that works just fine. So I always try to encourage people to really build it themselves. I'm not a big fan of SageMaker for its cost, but at the same time, it's a low no-code solution to ML, so that's kind of hard to compete with, and you're just going to have to pay that premium for those types of services. In terms of actually like building out pipeline orchestration, I really like Azure DevOps. Airflow is really nice too. That's what we use for our AWS implementations. Managed Airflow is a little expensive, but if you host it yourself, it's pretty good.
GitLab?
I love GitLab. Don't get me started. Oh my God. GitLab is the best CI/CD for MLOps, I swear to God. It's just not a lot of companies for some reason like to adopt it. Well, we've recently moved away with it. A lot of our clients are looking for like highly robust security environments, hosting their cloud in some specific AWS partition, all that kind of stuff. GitLab really is, I think, more geared towards startups of like I'm just trying to get my code over the fence, and it has a lot of baked-in CI/CD. I know the AWS runners or GitLab runners is something we were using for a really long time, which kind of let us train models on AWS instances while just using pretty seamless GitLab CI/CD.
You just mentioned that you use Airflow to train to run your training pipelines. But you have Kubeflow there. Do you not use the pipeline?
We do both.
You do both.
Yeah.
It depends on the environment.
Yeah, that was my next question. Is your entire stack using Kubeflow, hosting Kubernetes, and you do all your
It's almost entirely client dependent at that point.
You do a lot of like use Kubeflow model versioning and pipelining.
Yeah, so we have some people that are working on like a GCP implementation right now. They're using Kubeflow. I personally am working on a project that's using ECR to version all of its models. So it just, it really kind of depends what the client's using.
I'm currently playing around with Argo CD's workflow.
I've heard of Argo, but I don't have any experience with it.
I'm betting you.
Yeah, the thing to call out here too is like, while we've made code for each of these platforms to perform MLOps, essentially what we've created is like infrastructure as code, an accelerator for us to get started on a client that we might go on to. So it really just depends on the client requirements for cost, scalability, latency.
Can you go back one slide, Joe?
Yeah, sure. You want to reference it?
Yeah, this guy. So kind of the whole point of this, right, is this is where our data scientists are. They're always going to be working on this, iterate on the model, give me a new data set, what's my newest, best metric. And the rest of this, if you're a data scientist, is annoying. Oh my God, I don't want to write ADO pipelines for my entire life. It's hard. So what we've done is just kind of built all, like Cole said, the infrastructure as code, the kind of quick accelerators around it so that instead of saying, yeah, I got to go figure out some SageMaker endpoint, you just run the deploy to SageMaker endpoint function that we built out. Any other questions? Awesome. Well, I hope you guys like the MLOps. I hope you believe in it as much as I do.
Thanks for your time.